Polynomials, degrees of polynomials, and addition of polynomials. This lesson, there's a little bit of vocab, may or may not be new to you guys, and then adding polynomials is super easy. You guys have been doing this for a while this year. So how do we know a mathematical expression is a polynomial? So there's three things that make something a polynomial, and you guys are just going to have to write these down. This is the vocab part that I'm talking about. So first, each algebraic expression is the form of ax to the n. So something like 2x squared or 1x, really anything like that. The numerical coefficient of each algebraic expression, a is a real number, so just any sort of number we know. It's not. I don't think we're going to try and trick you on that one. Third, the exponent of the variable n is a positive integer, or it is the number 0. So this is the one that might trip you guys up. No negative exponents, no fractional exponents. I know we don't really do those yet, but watch out for the negatives and the fractional exponents, because those ones are no good when it comes to polynomials. You guys can grab the rest from a neighbor if you didn't finish. So which of the following are not polynomials? Well, let's look at these guys. Who thinks they know one of these things that's definitely not a polynomial? Drew? Yeah, 3xy to the negative 6. We have this negative exponent, so this one's definitely no good. Who knows another one that's definitely not polynomial? What is this z down here really? If I wanted to put it in the numerator, what would I have to do? Make it a negative exponent, right? So that one's not a polynomial either. It's got that variable in a fraction, which is no good. Do you think there's anything else on here that's not a polynomial? Isaac? Negative 2 to the 0 is a polynomial. It's sort of tricky. So anything to the 0 is 1, right? So this, if I wanted to rewrite this, is actually negative 1. But this, I could rewrite this also as negative 1x to the 0, because x to the 0 would turn into 1. So just a number, just a constant by itself is a polynomial. If this were a negative exponent, then it would be no good. Actually, that's sort of tricky. That would still work. We'll make sure there's no tricky ones like this in your homework. We'll go over it together. But this one actually is a polynomial. These two with the negative exponents are the only ones that are not polynomials. Okay. Number of terms. We have special names for ones that have certain numbers of terms, polynomials. How many terms do you guys think a monomial has? Micaiah? Yep, one term. So examples of these would be things like just x. We could have like 5x cubed. We could have like 2xyz. Something with one term that's attached with multiplication. So multiplication, everything has to be a chunk together for it to be a monomial. How about binomial? How many terms do we think that has? 2, yeah. 2 terms. Okay, so 2 terms could be like x squared plus x, or 1 plus x cubed. All right, how about trinomial? 3 terms, just goes in a row. So we could have stuff like x squared plus x plus 1. Anything with 3 terms where each term is attached with multiplication. These dots everywhere now. Oops. All right, so polynomial. This one is probably the one that's been the most important. These ones you guys can probably recall from memory with these prefixes. A polynomial is all of the above. And anything with more terms. something has more than 3 terms, we would just call it a polynomial. You can call it a certain, I don't know, certain amount of terms polynomial. But we don't have special names for the other ones. So all of the above and anything with more terms, anything obviously being ones that apply or that have our polynomial rules that we just had on that that first slide. All right, now we're going to do degrees. What is the degree of each term? So degree is actually the highest exponent, but these ones are kind of tricky because we have some things that have 2 variables. Whenever we have more than 1 variable, we have to add the exponents. So you guys might want to make yourself a note, more than 1 variable. We have to add the exponents. So we're going to find the degree, which is just the number and the exponent. So 4x cubed, what would the degree be? It would be 3. We don't have to do any adding because we just had 1 variable. 6xym is an example of when we'd have to add the exponents because we have more than 1 variable. So we have x, y, and m. None of these have exponents on them, so they're all just 1s. So we would add these up, 1 plus 1 plus 1. Our degree is 3. What's the degree of this one, you guys? 5. How about this one? 5. We just add those exponents. Good. How about this one? This y has a 1 on it. So we do 2 plus 1. We get 3. 1, 1, 1, 1, 1, 5. Yeah, you guys probably won't see these ones very often unless it's just asking you what's the degree of this term. Something like this isn't super practical, doesn't really mean a lot for us. So pretty easy though to just find the degree. All right, what is the degree of the polynomial? So when we're trying to find the degree of a polynomial, we're looking at the term that has the highest degree of its own. So like for this one, we have 3x squared. These ones all have 1s on them. So if I wanted to find the degree of just this term, what would that degree be? 3. So this one has degree 2. This one has degree 3. This one just has degree 1. So if we're finding the degree of the whole polynomial, we look at the biggest degree, like the biggest term, I guess, the highest degree on a single term. So this one would be 3. Just look for that highest degree in the whole polynomial. 4x to the 5th. This is y to the first x cubed, so my degree here is 4. This degree is just 2. And this degree is actually 0. Not sure how much we're concerned about that. The reason for that is this is 2. If we put an x with it, it would have to be x to the 0, because x to the 0 is just 1. We might go over that more later. I wouldn't worry too much about that because we're just looking for the highest degree term anyways. So in this one, what's my highest degree term and what's the degree going to be? 5, right? Just the highest one in the whole polynomial. So you want to go through and see what the degree of each term is, pick the highest one, and that's your degree for the whole polynomial. All right, addition of polynomials. This is pretty easy, you guys. We've been doing this when we're solving because we always start by combining like terms, right? So this is just some more combining like terms. Sometimes subtraction is a little bit trickier. Addition is pretty easy. So I have parentheses, parentheses, and then a plus, and then another set of parentheses. So if you guys want to think about it in terms of distributing, which is going to make it a lot easier when we start to subtract, this is really like plus 1 times this stuff on the inside. So since it's plus 1, we don't really have to change anything. We can just rewrite it as x cubed plus 3x squared plus 2. Now if I'm distributing a plus 1, I'm just really rewriting the terms. So plus 2x cubed plus 4. So you guys are going to want to start by just rewriting it without parentheses. Make sure everything is just together. and then we can combine like terms. So first I'm going to look at my x cubed. I have 1x cubed, and I have a 2x cubed over here. So total I have 3x cubed. I kind of like to cross them off as I go. You don't have to do that, just to make sure I get everything accounted for. And then I'm going to go to my x squared. So I'm going to have 3x squared, because it's the only x squared. And I have 2 and 4. 2 plus 4 is 6. So we're going to add it. Something that I want you guys to always do, usually we aren't too particular about this stuff, but always put your answer in order by degree. So start with the highest degree, so 3x cubed, and then go down 3x squared plus 6. That's just sort of like how it works in the math world, Isaac. How I got this term? So I had this x cubed here, and then I had plus 2x cubed here. So 1x cubed plus 2x cubed gives me 3x cubed. Yeah, just combining like terms. You guys have been combining more confusing like terms. Yeah. I might give you guys like a 1-day buffer, but I probably will, yeah, because later on it does get helpful if you have them in the right order. Right now it just seems silly, but it's not too tough to just start with your highest one and then move down. All right, let's try another one, a little bit bigger. Okay, so this is what I was talking about, you guys. When we have negatives out on the front of the parentheses, it's when it gets a little bit more tricky. You don't want to forget about this negative. Because it's out on the front of the parentheses, it has to be distributed to everything inside of the parentheses. Just like when we were solving and we had those tricky negatives that we had to multiply through. This is another tricky negative. We're not solving, we're just distributing. So this is like negative 1 times everything in the inside. So if you guys like to do the little arrows, we have to distribute this negative to every single piece to start. And then I have plus, this is really like plus 1 times everything on the inside of here. So we can really just rewrite what's in the second set of parentheses. So to start, I'm going to do negative 1 times this stuff on the inside. So I'm going to get negative 3x to the 5th. Negative 1 times positive 6x to the 4th is negative 6x to the 4th. Negative times a negative gives me plus 7x cubed. Negative times a negative gives me plus 5. So my first set of parentheses taken care of. And this one's just addition, so this one's a lot easier. I can basically just rewrite what's on the inside of my second set of parentheses. So plus x to the 5th minus x to the 4th plus 3x squared minus 2x minus 8. So this is a point where I'm going to say, okay, I'm going to start with my x to the 5th terms just to make my life a little bit easier so I don't have to rearrange them afterwards. So I have a negative 3x to the 5th here and a positive 1x to the 5th here. So Isaac, if I did my x to the 5th terms, what would I get? Negative 3x to the 5th plus 1x to the 5th. Good, yeah, negative 2x to the 5th. With really big ones like this, you guys, I really would advise you to just cross them so it gets a little easier as we keep going. Negative 6x to the 4th, and I have a negative x to the 4th over here. Riley, what would I get if I added those together? Good, yeah, negative 6 minus 1 is negative 7x to the 4th. Sweet, got those taken care of. Now I have an x to the 3rd here, and I don't have any x to the 3rds on this other side, so I'm just going to rewrite it because he doesn't have any friends to combine with. So it just stays the same. Same with this x squared. This is the only x squared I see, so I'm just going to rewrite plus 3x squared taken care of. And then minus 2x, I don't see any other terms with just an x on them. Minus 2x. Plus 5 minus 8 is going to give me minus 3. So just go in order as you're doing your adding and you'll be in good shape. Just like when we did it before, like terms, it has to be exactly the same, so it has to have the same variable, the same exponent, and the only thing that can be different is the number on the front, and then we just add the numbers. So you guys have been doing really complicated like terms, so I think you'll probably be in good shape. I'm going to have you guys try this one on your own. So try this one on your own and then compare with a partner. The largest exponent perfect, so we look at this term because it has a degree 4, and it's the highest degree out of any of these terms. So the degree of this polynomial is 4. Great, hopefully you guys all got this as your answer. This is like old news for you guys, so just the vocab is probably the only new thing. Grab a whiteboard.